Lesson 2.3 is on multiplying and dividing integers. And one of the first things I want to introduce is the inverse property of multiplication. This is similar to the property of opposites that we used with addition, where we said that a number and its opposite add up to 0. But with multiplication and division, we don't use the term opposites, or if we do, we're using it incorrectly. We use the term inverse, and they're very similar in meaning. If you invert something, you turn it upside down, which is like making it be in the opposite position that it was. But opposite is a term that we use with addition and subtraction, and inverse is the term that we can use that for both addition and subtraction, but also for multiplication and division. So the inverse property of multiplication states that the product of a number and its reciprocal is 1. And you could substitute multiplicative inverse for the word reciprocal. The product of a number and its multiplicative inverse is 1. Or to make it simpler, you could just say the product of a number and its inverse is 1. So what is an inverse of a number? What's a reciprocal? Well, if the number is a over b, then the reciprocal, or the inverse, is b over a. If the number is just n, what would be the inverse? Well, it's n over 1. So the inverse would be 1 over n. So if you take a fraction like 3/4 and you multiply it by its inverse, or reciprocal, or multiplicative inverse, which is 4 over 3, you get 1. 3 times 4 is 12, and 4 times 3 is 12. I'll just write it this way. It's 12 over 12. And that's 1. The product or quotient of two integers with the same sign is positive. So if you do 5 times 3, positive 5 times positive 3, you get 15. You also get 15 if you do negative 5. I'm going to put it in parentheses, times negative 3. They have the same sign, so that product is positive. 6 divided by 3 is 2, and so is negative 6 divided by negative 3. It's positive 2. The product is the answer to a multiplication problem. Quotient is the answer to a division problem. The product or quotient of two integers with the same sign is positive. The product or quotient of two integers with different signs is negative. So if we have negative 10 divided by positive 2, that would, according to this rule, result in negative 5, which we can prove to be true by cross-multiplying. Multiply 2 times negative 5, and we get negative 10. Multiply negative 10 times 1, and we get negative 10. So it proves that it's true. And then that kind of introduces the rule also that when you multiply numbers with different signs, you get a negative number. So let me just put an example of that out there. 3, let me make it a positive 3. 3 times negative 4, according to our rule, would be negative 12. Well, here's a proof of that, or sort of intuitive proof. If you're multiplying by 3, it's like adding this number 3 times. So if we did negative 4 plus negative 4 plus negative 4, if we add the 3 4s together, we get 12. And since they're all negative numbers, it's negative 12. So it's a sort of an intuitive proof of how 3 times negative 4 is equal to negative 12. You've been sitting in math class for like 20 years, and your teachers are always telling you that you can't divide by 0. It's impossible. You don't get an answer when you try to do it. So any number divided by 0, undefined, impossible, doesn't exist, don't even try it. Massive mistakes will result. So here's a little intuitive proof of it. You know, if you do 6 divided by 2, you get 3. And to prove that's true, you can take the number you're dividing by and multiply by the quotient, and you should get the dividend. So let's see what happens. If we do 2 times 3, we get 6. So let's suppose there is an answer to 7 divided by 0. We'll call it n. That tells us that n times 0 equals 7. And there's a contradiction there because you know that n times 0 is 0, not 7. So when we assumed that we could do this and get an answer, we got a contradiction over here. And in logic and in math, if you make an assumption and get a contradiction, logical reasoning tells you that your assumption was incorrect. So it's incorrect to assume that 7 divided by 0 is any number, because it's actually not. Any number divided by 0 is undefined. So don't try this. No division with 0 is permitted.